Hello, this is Praveen. Welcome to .NET for C Sharp training. Here is Module 1 and Session 4 agenda items. The Session 4 agenda C Sharp data types and memory management. So we'll try to know about the C Sharp. We'll try to introduce C Sharp data types and memory management. So we'll walk you through all the data types in C Sharp that are available in C Sharp, and we will go through the memory management in C Sharp in terms of stack memory, heap memory, and global memory. And we'll also go through the common type systems and common language specifications as well. So let's get started. Here are the list of data types that we have in terms of the C Sharp. Like the basic, like we'll get started with the integer types. In the integer types, we'll have the signed integers and unsigned integers. So later we have floating data types, and we have string data types and other data types as well. Okay, so first we'll try to know what are integer data types. So basically in integer data types, we will have signed integers and unsigned integers. Signed integers are something like which can hold positive and negative values. So if you can see in this particular chat, like in this particular table, like you can see it can hold all the signed integer can hold the positive and negative values, like in terms of you can see the data type, size, and the range. So s byte is the smallest unit, like the smallest byte, which is of 8 bits, and it can store a range of -1 to 8 to 1 to 7, and then followed with the highest level of next level of data storage is the short, and the one is the integer, where you can store a bigger range than compared to the short. Okay, and then the long, which is more bigger than the integer. So this particular thing, if you can see this, the signed integer, which can hold the positive and negative values. Okay, whereas the unsigned integers are like which can only hold the positive values, and it cannot store the negative values. Like, so if it is like it is like unsigned integers, the same format like for s byte, like we have byte, u short, u int, and u long, which is nothing but the unsigned integers. And in unsigned short, unsigned integers, and unsigned long, all these particular set of integer values which can hold the numeric values, only the positive values. So there is no question for negative value storage. We have to go with the signed integers. Okay, so frequently you will come across the integers much in your application. So take the note of this particular size of 32-bit, and this particular, it can have the range of this level of range. It is, and it is represented as a signed 32-bit integer. Okay, I'll walk you through all this particular thing I'll connect to my tablet in the coming soon. But let's see, and for now, look into this particular presentation in terms of the floating point. Like the floating point have the float, double, and decimal. Okay, this can hold the fractional data, like it can have the decimal values. Okay, and float can have a precision of 7 digits of precision, and double of 15 to 16 digits, and decimal of 28 to 29. Okay, if you can see these particular ranges, and here are the ranges and the sizes for this particular floating point. And character data type, we have the char, and it can hold a single character value, and it is represented with 16-bit unique character. Okay, and we'll have the string data type and string builder and other data types. Like we'll also go through some of the other data types, object data types, or var, and which can hold the any data type at this runtime or the compile time. Okay, so let me connect to my tab. Yeah, it's got connected. So basically, like we have to know the each and data types in C sharp, and what are each data type ranges, sizes, and the categories. Okay, so first we'll see what are C sharp data types. So the main categories that we have to discuss is like the first is like the integer data types. The second thing is the string floating data types. The third one is the string data types. Okay. And the fourth one is the other data types. In integer data types, as I said, like it has signed integers. We have something called as signed integers and unsigned integers. Signed integers can have positive and negative. It can hold positive and negative values, whereas unsigned integers can have only positive values. Okay, so in most of the applications we will be using signed integers for which can hold the positive and negative values. So the single value, the least value that can the starts with this particular signed integer is s byte. Okay, short, int, long. Okay, in this particular other side of unsigned integers, like we have byte, u byte, u short, u int, and u long. So this particular thing, like you unsigned integers can have only the positive values, and this can signed integers, this can all have the positive and negative, and this can have only positive. Okay, now let's see what are the floating data types. Floating data types, you will be having float, double, and decimal. So floating data types, like float data types, can have 7 digits decimal. This can have 15 to 16 digits, and this can have 24 to 25 digits of precisions. Okay, let's understand what are these particular precisions in detail. Like when we say like floating can have 7 significant digit numbers, nothing but it can have the total number of significant digits, like from the left of this particular decimal and to the right of this particular decimals. Okay, so nothing but number of significant digits, both sides of the decimal, should not exceed 7, more than 7. Okay, so number of significant digits on both sides of the decimal should not exceed more than 7. So what does it mean? Like, so I will give some examples, like let's say 0.1234. This number of significant digits in this particular decimal point is nothing but it is 4, right? So it is not exceeding more than 4, so this is valid. If I say 1 2 3 4 5 6 7, this is also valid because it is not exceeding more than 7. This is for float. Okay, float is for only 7 digits, so precision is 7 digits, right? So if I say like 0.1 2 3 4 5 6 7 8, and this is not valid. Okay, because it is exceeding more than 7. So in this particular thing, like it is same applicable to double and decimal. Doubles, like it can have higher precision than compared to the float, up to 15 to 16 digit, whereas in the decimals 24 to 25 digits. Okay, so nothing but you can have this particular onto the total significant digits for double, it can be 15 to 16 digits, and for decimal it can be 24 to 25 digits. So in this particular thing, like based on the number of precision values, number of significant digit values will decide the whether to go with which particular float or double or decimal. Okay, this is the categories for in terms of the floating data types. Okay, for string data types, like if you wanted to store a single character, then you have char data types. Okay, and for multiple characters, like if you wanted to store some string data, I can have the string data type, and we also have something called a string builder. Okay, so in this particular string categories of data types, you need to understand like string is immutable object and string builder is mutable object. Nothing but when we declare something, and once we assign some values to that particular string, and we cannot change that particular values, so that will be fixed in terms of the heap memory allocation. So that is nothing but immutable. So I will explain you that in detail. Let's say I have string str1. I'm declaring something called as string str1 is equal to hello. String str2 is equal to .NET Gurko. Okay, I have, and I wanted to make some changes into the string one. So I wanted to modify this something like this: str1 is equal to str1 plus str2. Okay, I'm modifying this particular string one, something called as str1 plus str2. So nothing but I'm concatenating that particular string. So what will be the result of this particular thing? str1 is equal to, then str1 will be equal to hello .NET Gurukul. Okay, I hope you're understanding. Like, so when we are trying to make any of the modification to the strings, so the it doesn't, it doesn't change the original value, but it goes to it is going to completely close that particular reference point of the string one, and it is going to create a new memory allocation. Nothing but, let's say, when you first declare this particular string str1 is equal to hello, so it is going to store hello in this particular format. Okay, and str2 .NET Gurukul. So when you say str1 is equal to str2, str1 plus str2, so str1 is not going to change here with hello world. Either it will completely going to break this particular heap in the memory, and it is going to create a new instance which is going, this particular str1 is now referring to this particular hello world, hello.NET Gurukul. Okay. Okay, nothing but if you want me to explain it again, I can explain you. Let's say I have this str1, okay, which holds the hello. Okay, when we are trying to change certain value to this particular str1, it is not going to change in this, we are in the heap memory location. It is not going to change in this particular memory allocated memory of the heap, but it is going to completely remove this particular reference and create a new instance of this particular memory. New memory will be allocated to this particular str1, which will hold the hello world, hello.NET Group, something new, the new values. Okay, so it is never going to change the allocated memory. Okay, so this is nothing but the immutable objects. So whereas in terms of string builder, it is going to change the original value. So it is nothing but str1, earlier it has hello, right? So it is going to change this value to hello.NET Gurukul. So mutable objects, I'm going to write here for your reference here onto the left side. Okay, once object get created, values won't change. The modified create new object. creates the new object. So once the object gets created, the values won't change. The modified creates the new object. Okay, in this particular sense, it's called the immutable object. Okay, I hope you get what are mutable and immutable objects. Okay, and other data types are like we have something called as where data type, and okay, we have dynamic, we have something called as object data type. So this particular where data type, object dynamic and object data types can hold any data type. Okay, so where data types, the type of that particular variable is decided on the compile time for where, and for dynamic it is for the runtime, and for the object it is decided on the fly. Okay, so for the object it is like the mixed one. Okay, so for where object, the type of that particular variable is decided on the compile time, and for the dynamic, like the type of that particular variable is decided on the runtime. Okay, so here are the list of C# data types. Like, so I hope you understand, like in terms of your integer types, floating data types, string data types, and other data types. So in when it comes to the integer data types, you have to all that you need to remember that it has to be signed integer. We have something called as signed integers and unsigned integers. Signed integers can have positive and negative values. Unsigned integers can have only positive values. Okay, and this here are the list of the signed integers and unsigned integers. So here this all these values mostly it used in your applications, which is holds the positive and negative values. Okay, and floating data types, you'll have float, double, and decimal. And float is like 7-digit numbers. Precision, it can hold 7-digit precisions, and double, which is 15 to 16, and this is 24 to 25 digits. Okay, you can see here in this particular string data types, like you will have the mutable and immutable objects. Okay, something you have to know that once this particular string is been declared and assigned some values, you cannot change that particular value. That object, the created values won't change. The modified created new objects, the modified creates a new object that in that particular things we call as the immutable objects. Okay, so let me tell you something about the common type systems and common language specifications. I'm writing it on the bottom, so I have less space. So common type systems. See, whatever this particular integer, floating, strings, and other data types we have. So similarly, we'll have in the not just in the C#, we'll have also the same thing in the VB.NET, J#, .NET, everything of whatever the Microsoft languages it supports, everything that particular thing will have this particular same formats of having the integer, floating, string, and other data types. Okay, so whenever I declare is as integer I is equal to 10, or dim a as integer, this both whatever we write in whichever the syntax is difference, it will convert into 32 dot, it will convert to system dot into 32. Okay, it will convert into system dot 32. So whereas in the string format also, whether you write string str1 is equal to hello, or if you write dim str1 is equal to hello, so both it will convert into system dot string, system dot string. In this particular thing, like we call them as the common type systems. Okay, so common type systems are nothing but like whatever these particular data types which are, if you are all the listed, it will have the same format in terms of the in any of the languages, only the syntax is the difference. Okay, so I hope you get the all the data types in this particular thing. So the thing is like the all this particular we are seeing all this particular in float, and but in this on the all the data types onto the left, I call them as the value types, which stores on the stack memory. On the left, onto the right side, like if you can see, all these strings and other data types will comes under the reference type, which stores onto the heap memory. Okay, so here are the value types and here are the reference types. So you need to keep in mind, like the integer and the float data types comes under the value types, and this particular thing, string and other data types, will comes under the reference data types. Okay, which reference types which comes under the heap memory. Okay, the same thing has been explained over here. The stack memory, like the stack memory is like comes with the characteristics of last in and the first output. Okay, in this particular manner. Okay, so whatever the data types onto your right side on the strings and the other data types, your all class and all thing, everything comes under this particular heap memory. Okay, so we, apart from stack and heap memory, we'll also have something called as global memory, which all the static members in these particular variables are stored in this particular global memory. So it's a simple straightforward rule that whatever the variables that we declare in terms of a static variable, that stores in the format of in that stores in the global memory. Okay, I hope you understand what are the different data types we have, and which data types comes under which particular category, and what is the memory's location for that particular data types. Okay, see, common type systems, like I said you, like whatever the data types we have, in whatever the listed data types we have, it is common for each and every .NET languages. It is consistent across the all the .NET languages. This, it is applicable for all the languages. The thing is, like, only the syntax difference is the key. Okay, so if I declare in the C sharp like something called as int age is equal to 30, and something in the VB.NET, so age as integer is equal to 30, both are the same. So this your compiler will convert this particular integer data types into system.int32. Okay, so your compiler will treat the same way, because your C sharp compiler will convert to its system into the 32, and your VB compiler will also convert it to the system into the 32. So CLR will treat both them as the same way. Okay, it doesn't matter whether it is C sharp .NET or VB.NET or F sharp or J sharp. Okay, your C sharp doesn't, your compiler does not, your CLR doesn't know about it. It does not aware of it. Only the compiler duty is to convert that particular data types to the relevant data types, common language, common type systems. Okay, so similarly, when you write as string name is equal to Alicia in C sharp, or dim name as integer as Alicia in VB.NET, it will going to convert system to system.string, and that will be taken care by the CLR. Okay, common language specifications, like when we develop any of the methods or classes or anything, so it has to be have some specific rules, like in terms of that particular classes or methods or whatever we write, it should be wrapped under the namespace, and the particular namespace should be have some DLL or wrapped onto the top of it. Okay, so here is the simple, like in terms of whatever the type systems, like whatever methods or blocks of statements that we write in this particular class should be in wrapped to that particular methods. Okay, a class should have methods, and that should be wrapped under on the top of it. You should have the namespace and the DLL, so that there should be a, when you build a particular DLL, and that particular DLL developed in either in C sharp or VB.NET, it can be used in any other languages, which is nothing but the language interoperability. So based on the standards that we follow, we call this as the common language specifications. So in order to communicate to the other languages as well. Okay, so here is nothing but the common type systems and common language specifications. Okay, so let me walk you through an example of this. I have the list of all these particular variables and all the data types. I have listed all the value types. Here is the value types, nothing but the integer data types and the unsigned integer data types. Okay, so floating, doubles and decimal. Here is the our floating data types, and we have the character data types, and we have something called as string data types, object and variables. Okay, all these are nothing but the, as I said, like these are the reference types. Okay, so as I told you that this is the signed integers which can hold positive and negative values. So if I give -10, also it is going to take. Okay, it because it can hold the positive and negative values. So for unsigned integers, if I give -10, it is not going to allow me. Okay, it is saying that this is not possible. Okay, only positive values are possible in the signed integers. Okay, for float double, only 7 to up to 7 precision value I can store, so I can give this particular thing. Okay, so for double I have a bigger precision value, and for decimal I have till 25 to 26 digits. Okay, here is the list of the value data type. Okay, which is nothing value value types, which are nothing but which all stores in the stack of that particular memory. Okay, from here if you can see, these are the reference data types. Reference data types like character. Okay, okay, reference data types, this still comes under these particular value types. All this comes under the value type. Even your structure comes under the value type. Character, boolean values, enumerator. Okay, structure, all this comes under these particular value types. Okay, from here, from the string and object, dynamic, where, and all this stuff like class. Okay, all this comes under this particular reference types. Okay, let me run. This is the high level overview of a simple sample program of data types. Okay, if you can see, these are the value types: integer, okay, float, double, character and boolean. All these are the value types, and this can be stored in the stack. Okay, and your enumerator and structure also comes under the value types. Okay, here are the reference types, like in terms of your string value, object value, dynamic value, variable, var value, and arrays or class, everything like in terms of your reference types. Okay, the static memory, like the static variable, I have a static variable over here as well. If you can see, I have a static class and I have the static members. In this particular, I have this particular static variable in this particular thing. So in this particular thing, like I call them as the static members. I call them as the static. It is memory is allocated in the static memory. Okay, so I hope you understand what are the different data types we have. Okay, what are value types and what are reference types, and the stack memory and the heap memory, and what is immutable and mutable objects, and what is common type systems and common language specifications. Okay, let me rewind for you. Like in terms of, we have seen what are different data types we have, and the memory allocations on in terms of the stack, heap and global, and we also seen common type systems and common language specifications as well. So in the next session we will deep dive into in terms of the variable declaration, casting and overflowing checksums, like something we have to know about more about the value types and the reference types, and we'll see the data types and declarations. And we have something important in terms of this particular session 5, like implicit and explicit casting. So sometimes we may have to store the one data types to the another data types, so we have to cast the data as well. Okay, and we'll also see what are checked and unchecked blocks for the overflow checking as well. Okay, so let's catch up in the next session. Thank you, thanks for watching.